everyone, I'm Franklin Solancho and I'm here to discuss some topics from Module 6, 7, 8. These are the lessons that we'll be covering up. Firstly, we'll define what a network is, some types of networks and categories, the point-to-point and point-to-multipoint setup, and also the definition of computer network. Then we have the media access controls, some groupings and techniques, plus some examples of it. And next is the IEEE. There will be a brief introductions about this organization and some common LAN standards. Aside from that, we have the OSI layers, which also be discussed in summary. And lastly, the Internet Protocol. A system of interconnected computers and computers peripherals such as printers is called computer network. This interconnection among the computers facilitates information sharing among them. Computers may connect to each other by either wired or wireless media. Computer networks are classified based on various factors. They include geographical span, interconnectivity, administration, and architecture. The point-to-point communication is a simple topology that displays the network of exactly two hosts or either computers, servers, switches, or routers connected with a cable. Point-to-point topology is widely used in the computer networking and computer architecture. It is also used in telecommunication system when we speak about the communication connections of two nodes or two endpoints. Point-to-multipoint communication is accomplished by a distinct type of one-to-many connection, providing multiple paths from a single location to a multiple location. Networks can have many stations using a single channel or medium. All the stations use the medium to send data to each other. Because essentially a shared resource, a station needs to follow rules or protocols for proper access. This is what we call the medium access protocols. Medium access protocols can be categorized into four techniques. We have the fixed assignment technique, random assignment technique, demand assignment technique, and lastly the mixed strategies technique. In fixed assignment technique, it allocates the channel in a static manner, unchanging and independent of the activity of the terminals. There are three types of fixed assignment techniques, namely FDMA, TDMA, and CDMA. FDMA, which stands for Frequency Division Multiple Access, divides one channel or bandwidth into multiple individual bands, each for use by a single user or node. Whereas for TDMA, Time Division Multiple Access, user nodes used to share the same frequency channel by dividing the signal into different time slots. Whereas lastly, the CDMA or the Code Division Multiple Access, it allows numerous signals to occupy a single transmission channel, optimizing the use of available bandwidth. Next is the random access technique. In this technique, the terminals share single channel and use that channel randomly. The most basic type of random access technique is called the pure aloha. Terminals transmit data to the central terminal, and the central terminal replies back with an acknowledgement that everything went well. If the remote terminal does not receive a response, it will transmit the data with a random amount of delay. Next example is the CSMA/CD, short for Carrier Sense Multiple Access with Collision Detection. It is a media access control protocol which defines how network devices respond when two devices attempt to use a data channel simultaneously and encounter a data collision. The CSMA/CD rules define how long the device should wait if collision occurs. The medium is often used by multiple data nodes, so each data node receives transmission from each of the other nodes on the medium. The next technique is the demand assignment technique, in which it's which is a protocol used in satellite communication, particularly very small aperture terminal or the VSAT system. It is a technique whereby a number of users share limited sets of channels. The principle behind this technique is that the channel allocation is based on the needs of the contending stations, and this falls under two categories. We have the central control and the distributed control. The difference between these two is the existence of central controller. On the other hand, adaptive strategies and mixed mode technique employs a mixture of the other methods and adapt according to demand. Next is the IEEE. It is a non-profit organization formed way back in 1963, which are composed of technical professionals which are dedicated to advancing technology for the benefit of humanity. It promotes the engineering process of creating, developing, integrating, sharing, and applying knowledge about electro and information technologies. IEEE is one of the leading standards making organization in the world. It performs its standard making and maintaining function through IEEE Standards Association. One of the notable IEEE standards is the IEEE 802 Landman Group of Standards that includes the 802.3 or the Ethernet standards, and lastly the 802.5, which is also known as the token passing. Next slide is the 802.3, which defines the physical layer and the media access control of the data link layer for wired Ethernet networks, generally as a local area network technology. Examples of physical medium being used are 10 base 2, 10 base 5, and 10 base T. The 10 is the 10 in the media type designation refers to the transmission speed of 10 Mbps. The base refers to a baseband signaling, and the T refers to represents the twisted pair. If the cable is a twisted pair. 2 and 5 refers to the coaxial cable length. The 185 meter length has been rounded up to 2, which is short for 200, and 5 for 500. In the access method known as token passing, special type of packet called token, it circulates around the cable ring from computer to computer. When any computer in the needs to send data across the network, it must wait for a free token. When a free token is detected, the computer will take control of it. If the computer has the data to send, the computer can now transmit the data. The data is transmitted in frames, and additional information such as addressing is attached to the frame in the form of headers and trailers. When the token is in use by this one computer, other computers cannot send data because only one computer at a time can use the token. No contention and no collision takes place, and no time is spent waiting for computer to resend the tokens due to network traffic on the cable. Next topic is the Open System Interconnection Model, or the OSI model, which is a conceptual and logical layout that defines network communications used by systems open to interconnection and communication with other systems. The model is broken into 7 subcomponents or layers, each of which represents a conceptual collections of services, the layers above and below it. We start with the presentation layer, also known as the layer 1, then followed by the data link, network, transport, session, presentation, and lastly, the application layer, or the layer 7. But we'll discuss about more of network layer. The network layer is the third layer of the Open Systems Interconnection Model. And that layer provides data routing paths for network communication. Data is transferred in the form of packets via logical network paths in an ordered format controlled by the network layer. Some other functions aside from routing are logical addressing, data encapsulation, and fragmentation and assembly. The last topic is the Internet Protocol. It is a set of rules governing the format of data sent over the Internet or the other network. And here are the following function. For one, it provides basic unit for data transfer. Second, it provides addressing. Third, it performs fragmentation. And lastly, it facilitates routing. Thank you for listening. Bye.